Solving right triangles. Solving right triangles is an important piece of geometry, and we'll see some applications of it later. We did one example in the last set of notes where we were trying to find the length and height of a skateboard ramp when we knew what angle we wanted it to be at and we knew how long we wanted the skateboard ramp. So some other really important geometry concepts will be done using trig ratios and solving right triangles. And we'll talk about what specifically solving means in geometry in a few minutes. Right now, let's talk about missing side lengths. So we saw in the last set of notes that if you're missing a side, but you have an angle, let's say this is 30 degrees, we have 11, and we want to know how long this side is, we can do that using, well, this is opposite over hypotenuse. We could do that using a sine of 30 degrees. So essentially, to find missing side lengths, you want to use a trigonometric ratio. And your options for that are sine, cosine, or tangent, depending on which side you've identified. Like in this one, it was opposite and hypotenuse. So in that case, you would want to use sine. This is if you're given, so you must be given at least one angle and one side. So that helps us with the ratio, because as we increase or decrease this angle, the ratio between these two sides will change. So right now, they look about equal, but if I were to change this number, make it more of a skinnier triangle, let's say that's 22, then these become in a different ratio. Maybe it's 2 to x. And you could see how if we're doing sine of a smaller angle, that the opposite, the numerator of sine would be lower than in this one. Like this one would be 11 over x, and this one would be 2 over x. So in that case, we know that this fraction will be smaller because we're comparing these two sides, and this is a smaller side. Okay, so that's to find missing side lengths. We did that in the last notes, but I want you to realize you use the actual trigonometric ratio or trig ratio. We can also use these funny 3 trig ratios to find missing angle measures, but you must be given 2 sides at least. And what we can do to find angle measures is we can use what we call trig inverses. So this is another type of math application that will kind of do the reverse. It tells us, oh, we have the ratio, so maybe we knew, draw this triangle again, maybe instead of knowing this angle, we don't know it, but we know that the bottom is 11, and we know this is 14. Then we can actually find what this angle is by saying the inverse sine. Inverse sine will tell you the angle between opposite and hypotenuse. I shouldn't say between because that's really this angle. I should say with the ratio of opposite and hypotenuse. So in other words, if you plug into your calculator, I have an 11 opposite and I have a 14 hypotenuse, it will spit out what this angle is. So let's actually do that. And the way you do that, calculator instructions, you press the second button, I'll show you in a second, and the trig ratio that you're trying to reverse to get the angle and it'll tell you sine -1 on your calculator, and that means you're using the inverse. So trig inverses tell you angle measures if you have two sides. Let's see. Turn it on. So here, if I want to find my angle measure, I'm going to say second sine, and that just change it to this blue up here. So every button, because you don't have enough buttons on your calculator, has more than one function, but you have to be able to change the function. So we hit second, hit this, it comes up as inverse sine, which tells the calculator I want to find an angle if I have the ratio for sine as 11 over 14, my opposite side over hypotenuse. That is going to tell us, oh, that angle between those two sides must be 51.8. And that looks about right. It's an acute angle, right triangle. Yep. Okay, so let's do another example like that. So this question says, find the measure of angle A. So immediately, if I have my right triangle and I have two sides, I know that to find an angle measure, I must use an inverse trig ratio. Simply how your calculator is reading it. Is it reading it as a normal trig ratio, which is comparing two sides, or is it reading it as what is the angle if I know my two sides and how they compare, how they relate to one another? So here, if we're looking at angle A down here, mine's kind of light, we have the opposite side to angle A, and we also have the adjacent. What trig ratio inverse do you think we're going to use? Well, the one that relates opposite over adjacent is tangent. If you remember TOA, opposite and adjacent. So what I'll do on these is I'll say inverse tangent, telling my calculator I want you to find me an angle if I know the ratio between my opposite and adjacent is 15 to 20, or 15 to 20. Plug that into your calculator. Second, tangent gives me the inverse tangent of, I want to see, 15 over 20. That gives me the angle measure 36.9. Can round to the nearest tenth of a degree with me. So, you know what, I think let's do these together as well. So this one we're trying to find angle X down here, but we're given two sides here. So we're given the opposite side. What's this one? Yes, it's hypotenuse. Hopefully you said that. What is your only one from SOHCAHTOA that has opposite and hypotenuse? That is sine. So we know we want to use the inverse sine because we're looking for an angle. So I'm going to tell my calculator, find me an angle. That's this part. Find me this angle if I know the ratio of the opposite and hypotenuse sides are 23 to 47. All right, let's plug it in. Second sine of 23 divided by 47. 29.3. 29.3 degrees would be this angle right here. Now you have to be really careful when you do any sort of trig and plugging it in anyhow. You have to make sure that you have the correct order. So if I accidentally put hypotenuse over opposite, 47 over 23, your calculator will give you probably an error message. 47 divided by 23. Yes. So if you get an error message, well, that means you did something wrong. The reason that your calculator does that is because it knows the hypotenuse must be bigger than the opposite. So if you put an improper fraction, it's going to say, eh. The only one, remember we talked about in the first set of notes, the only one that can be greater than 1 is tangent. So if you were to put 47 for 23, your calculator would say, oh, that's greater than 1. Sine cannot be that. Eh. Okay, so when we talk about solving a right triangle, it's as if we're trying to know all of the sides and angles. So we want to fill the whole thing in other words. When we look at this first triangle, I look and I see, okay, I have 2 angles and I have 1 side. I want to fill in this, and this angle. So if you remember from triangle sum theorem, you could just subtract from 180 and find this angle. So we'll do that at the end. But for now, I'm just going to use this angle and some trig ratios. The reason I'm using trig ratios is because we know the angle. We want to find the side, so we don't need to use the inverse. We need to use the regular trig ratios. Okay, so from this angle, this side is across. It would be opposite. We know this one is the hypotenuse, and we know that this bottom side is adjacent. Let's start with x first. So I know that I have opposite and I want x adjacent. The only trig ratio that has to do with opposite and adjacent comes from TOA, or tangent. So I'll set up tangent of the angle. This is because we're trying to find a side, so we're not using the inverse. We're not doing the -1 thing, just the regular one, just like we did in the first notes. Tangent of 48 equals opposite 70 over adjacent, we don't know, x. We're going to do some algebra, multiply both sides by x. X tangent 48 equals 70. X equals 70 divided by tangent 48. So I'm just moving this around as if it was one big number. I will plug that into my calculator. Tangent, 70 divided by tangent of 48 equals 63. That's not right? Yes, that's about right. There's a big triangle, 70 over here. So x equals 63.0. Okay, moving on. Let's find y. So I ran out of room over here. I'm going to do it over here. So with y, remember I said use the side lengths they're giving you, because in case you did this one wrong, you don't really want to use ca or cosine, because if you got this one wrong, that'll make this one wrong as well. So use this one. So we have opposite, and we're looking for hypotenuse. The only trig ratio that has to do with opposite and hypotenuse comes from sine, because of so. So I'm going to say sine of the angle again, sine of 48, equals opposite 70 over hypotenuse y. We'll do some magical algebra again. We get y sine 48, we're just multiplying, equals 70. Y equals 70 divided by sine 48. X is one number, and that is equal to 70 divided by sine 48, 94. And if you want to check yourself, James, think about 94. Is that bigger than my other two sides? Yes, it is, which is good because this is the hypotenuse. 94.2, if you want to be exact. All right. And then last but not least, that would complete knowing all the sides. You could find the third angle by just subtracting from 180. So we've got 42 for this angle if you subtract from 180. All right, let's try that again with one more, and then I'm going to let you do this one for kind of homework. and see if you can try to do this using using what we've learned in this. We'll do one more together. All right, so I'm looking at triangle ABC over here, and it is different than this triangle ABC that we just did, because instead of being given an angle and a side length, in this one I'm given just two sides, no angles except for this 90-degree one, which when we're doing right triangle trigonometry, you really have to find one of the other angles, or you have to have one of the other angles. You can't use the 90-degree one. Okay, so let's, oh, and let me add why that is, because you're probably wondering. The reason that is because when we look at a right triangle, the hypotenuse is always the longest side. And in order to use trig ratios, you have to have a hypotenuse, an opposite, and an adjacent side. But when you do the 90-degree one, look which one is opposite the 90-degree angle. So this would be like the opposite and the hypotenuse side, and that won't work because then what do we call these two? They would both be like adjacent. So it doesn't work. Okay. Let's start by trying to solve for the last side. So we don't have any of the angles, so right now we can't use any of the trig functions. So if you think back, how could we find this hypotenuse side? What theorem could we use if we have the two other sides? You guessed it, Pythagorean theorem. So let's solve for that. We would get 10 squared plus 22 squared. This is if you have two sides of the triangle. Equals, oh, let me use h because they have h there, h squared. 100 plus, I don't know what 22 squared is, 484. And second square root of 5. Hopefully that comes out. So I did the square root of 584 on my calculator as h, and I got approximately 24.2. So this side over here is 24.2. Alright, so that completes our triangle in terms of sides. Now we need to complete these two angles. Once you find one of them, you can just subtract from 180 because you know this is 90. What I would do if I were you is use the angle or the side lengths they've given you, not this one. Just like with the other problems, if you mess up on this one, then your trig ratios will be wrong. So you might want to use just what they've given you. Now you could start with either of these. I'm just going to go for angle B because, I don't know, I like it today. So from angle B, 22 would be opposite. 10 is not the hypotenuse, but it's next to B, so it must be adjacent. Which of your trig ratios compares opposite and adjacent? That would be tangent, because TOA is opposite and adjacent. All right, let's set it up. I'm looking for an angle, so I know I'm not using the regular trig function. I need to use what we call the inverse. So I'm going to say inverse tangent, tell me the angle, calculator, if I know a ratio. So if you've noticed, when we do a normal one, we would put the angle inside of the trig function. When we do one where we're trying to do the inverse to find the angle, we actually put the comparison in the parentheses and the calculator will spit out the answer. All right, so the comparison of opposite and adjacent for angle B would be 22 over 10. And that will give us angle B. All right, let's figure that out. Put it in our calculator. Second, because it's inverse, tangent, 22 divided by 10. Your calculator will not give you an error message on this one because tangent can be an improper fraction, be over 1. Okay, so it's saying that angle B is 65.6 degrees. Then we can just subtract from 180 minus second. Oops, sorry. 180 minus second answer minus 90. So I'm just subtracting this 65 and 90, and it tells me that the last angle will be 24.4. So angle C will be 24.4 degrees. So I want you to try this one before our next session and try to complete it. So you need to find angle A, angle C, and side Z. Remember that when you're given two side lengths, you'll have to use inverse trig functions or trig ratios to find the angle measure of one of these. So you can either do C or you can do A. And then for Z, the side length, think about it's a right triangle. What theorem did we use in this one when we were given two side lengths? Let's see if there's a back. And that is it for this lesson.